welcome back to Digital Replay. Today we're doing modeling systems, which is only on one page in this first chapter in your textbook, but we come back to it multiple times throughout the year. So let's say you grow up, you get your education, and you get your job, right? Well then, with your job comes that paycheck, right? You get that money. Where do you put that money? Well, you put that money into the bank, and we call this money income. Right? Well, then you've got your job, and then you decide you need a car, and then maybe you get a girlfriend or a boyfriend, and then things start happening to your money, and we call those things, when we have to take the money out of the bank, we call those things expenses when the money's coming out, right? Okay, so we've got income going in, and it goes into the bank on a regular basis. Then we have these expenses, which is where we're taking the money out of the bank on a regular basis. And it looks almost like a little bit of a cycle, right? Or maybe some kind of system. Well, we can actually call it a system because it's a group of parts working together as a whole. There's the income part where you work your job and the money goes into the bank. And then there's the expenses part where you get excited and you say, oh, I want this new TV. And so you go out and buy it because you have the money for it. And that's another part. Then there's the part of the bank, which is the reservoir holding it all together. So let's talk about these little pieces here. The bank, the income, and the expenses. This is a simple system where the bank is the reservoir. Here's our sciencey term. The bank is the reservoir. It's the place where we're holding the money, right? The input is the amount of money that's going in to the reservoir. And then the output in this case is the expenses. It's the amount of money going out, right? So that's a simple system. A simple system is a system with one input and one output. Very easy to understand. Let's take another example of a system and let's make it into a simple system for now. Let's call this Lake Cochise system, right? There's a beautiful picture of Lake Cochise, and Lake Cochise is actually a reservoir of water, right? We hold water in there that we want to use later. And some water comes into the reservoir, and then water goes out to the reservoir when we need it. And it goes out through a dam, a little tiny dam. Here's the cool thing about systems is we can actually measure the flux or the change in the flow of what's going in and out. And according to the Yakima Basin website, the water going out of the dam is 301 cubic meters every 10 seconds. So 301 cubic meters every 10 seconds is flowing out of the dam. Wow, that's really cool. Flux is the rate of flow per unit area, but we're going to really focus on the rate of flow in this case, okay? So how fast is water going out? Well, 301 cubic meters per 10 seconds. We want to get it down to per second. How much water is coming out per second? Well, this is pretty easy math, right? All we have to do is divide. Divide by 10 is super easy. So the flux, or the amount of water going out of the dam, every second there's 30 cubic meters flowing out of the dam, and this is called flux. So let's take another very simple system. Here I've got my container, and I turn my water onto my container, and there's a little tiny hole at the bottom of the container. So water goes into the container at some rate, whatever rate I turn the water on. So let's say it's 10 cubic centimeters per second. It fills up the reservoir or the container, and then it flows out. Notice how the water level comes to some point and then flows out at the same rate that it's flowing in. So that is, the flux is the same at the input and the output. That means this system is in equilibrium. This system is in equilibrium. Okay? So now, let's say we increase the flow out of the faucet to 17 cubic centimeters per second. So now the flow is a little bit higher. Well, then the reservoir is going to fill up a little bit more, and then the rate at the end, what is the output rate going to be? Well, as long as the hole is big enough, the output rate is going to be the same because this is a system that's in equilibrium. Equilibrium is when the inputs equal the outputs, or when you subtract the outputs from the inputs, you get 0 because they're the same. In earth science, the systems aren't so simple. They don't just have one input and output. We actually have multiple inputs and outputs in all of our systems. So when we're talking about these more complex systems, we need to figure out a way to show the different inputs and the different outputs and how they're working together to make this system work. Let's use the example of a small pond. Let's say Inglehorn Pond here in Ellensburg, just off of CWU's campus. The pond is the reservoir. It's holding the water. Coming into the reservoir is some groundwater flowing up into the pond itself. And that groundwater is flowing in at a rate of about 17 milliliters per second. We also have a little bit of precipitation around here, and not much, so about 9 milliliters per second, let's say. It's raining right now in our pond scenario, and that's the rate at which it's raining. We also have evaporation that happens, and evaporation is where the water in the pond joins the other water droplets in the atmosphere because of the energy from the sun. So there we have some evaporation occurring. And there's also a tiny stream, and this tiny stream takes water out of Inglehorn Pond at a rate of about 20 milliliters per second. So the question is this system in equilibrium? Well, we've got multiple inputs. We've got groundwater coming in, we've got precipitation coming in, and we have multiple outputs. We've got a tiny stream, and we have a little bit of evaporation happening. Now notice that I've made my arrows different lengths depending on the size of the number. So a larger number is a larger arrow, and a smaller number is a smaller arrow. This is a really easy way in a diagram to show that this is not a very big output, but this is a much larger output. So is this system in equilibrium? Well, to find out, we'll take the sum of the inputs and we'll subtract from that the sum of the outputs. If it is in equilibrium, this equation will equal 0, because that's what equilibrium means, that the inputs and the outputs are the same. So let's do our little equation. We have groundwater coming in at 17, we have precip at 9, we have the 2 and the 20 for outputs, and we do that little equation, we find that no, in fact, it doesn't equal 0. It equals 4 milliliters per second, so this system is not at equilibrium. In fact, we also know that because this number is positive, this system, the reservoir, is increasing at this particular moment in time. It is increasing in volume by 4 milliliters every second. So the reservoir is growing. Earth processes can be represented by system models. Systems have inputs, outputs, and reservoirs, and equilibrium is when the inputs equal the outputs. This has been your digital replay for systems. We will see you next time.